So this is experiences using Grails in a microservice architecture. Just to let you know, this is available, the slides are available online already at bit.ly/Greach-micro. You should be able to get the same slide deck if you'd like to use it. Also, everything's up on GitHub if you really want how the slides are made, but there's nothing that special about them. It's mostly marked down. Oop. So, who am I? My name is Jeff Beck. I'm a tech lead at ReachLocal. I've been doing Grails since about the 1-2 days. That's apparently how I judge time nowadays, is just what Grails release I started at. Most of my day is working with a group of teams that aren't only in Grails anymore. So we have lots of different applications going on, and we've went towards a microservice architecture. So what I mean by microservice architecture is a single concern, and it is a single deployable thing. And I say thing because I don't care if it's a fat jar or a war or whatever it is, it's one deployable part. Now, what I don't mean by microservice is I don't mean under 1,000 lines of code. I've seen that definition out there, and I find that kind of arbitrary. I don't mean any particular framework or set of tools. What I really mean is just, here's a single concern. The other big part of this is it needs to be deployable in isolation. I'll let a couple more people come in. Okay. So what I mean by deployable in isolation is that I shouldn't require setting up any other microservices or any other supporting systems for my app to work by itself. And it may not be a product, but it will at least function and serve the single concern it has. Now, it still may depend on some infrastructure pieces such as a data store or an eventing system, but for doing its business logic, it shouldn't need to depend on any other services. So our architecture in general has become a very large sprawl over a number of acquisitions. So when I say we have a polyglot architecture, I really mean we have everything from Perl cron jobs running all the way up to Ruby and Rails apps serving the front end and hybrid mobile apps on the other side of the world. All working together. And what we're really trying to do is build small composable pieces that isolate each concern down to a particular technology. Now, a data service in our service architecture doesn't necessarily need to be in any particular language. So what we do is we try to figure out when there's a good fit or not. To give you a small example, this is kind of this is one very small part of our architecture. This does posting out to a social site or two, and you'll see all of these pieces working together to do that. So the areas that I'd like to call out in particular that will help with this talk is our event endpoint. So we use eventing in our architecture quite a bit as well. So, and we expose a REST API as well. So the subscription service you see up there, I'm going to go through a little more in detail, is a REST subscription service. And that is where it's acting mostly as a pure data store, but the special functionality there is every update or create in that subscription service is emanating events. That's basically letting everyone know that something has changed. Now, the important part is we then listen on virtual topics from ActiveMQ The virtual topics just act as a way of grouping some of the events into relatively large buckets. So it's not fine-grained subscriptions. So it's more of a broadcast model where you have people listening to general groups of events that can then be filtered down further from there. So where Grails fits for us right now in the microservice world is anywhere we're doing pure REST resources, Grails seems to be a really good fit for us right now. And anywhere we can use Gorham, we've found that it is a great way for us to use Grails. And that's really when we're choosing to use Grails over a lot of these other technologies, is when we can use one of these two or both of these technologies as part of it. But where Grails doesn't fit for us right now is batch jobs. We can use Spring Batch, and we can use other tools. And since we're doing a single concern in each microservice, there isn't really much benefit from us standing up a Grails app to be our batch job processor for us. Given if we only had Grails apps, that might be a different concern. We might have a different opinion there. So as I go through this, I'm trying to give you our personal experiences using it, and I will come out with what I think is the best case recommendation for when you can use Grails in a microservice architecture, and you'll have to kind of evaluate within your own company. Also, we have some microservices that lack any web endpoint. So there is no web to call, so there's not really a point for us to use Grails in that case. So I'm going to go through our subscription service, and this is our example app. It is one of our only source of truth in the company for whether or not one of our customers has a subscription to something. And it sounds like a very narrow focus, but for our company, we have a lot of things customers can subscribe to, and we were getting a lot of sprawl because every app was maintaining their own identity of whether or not someone was subscribed, which then made it very hard to figure out what customer actually bought from us. So that's kind of why we went to this. It exposes a subscription REST resource, so just a single REST resource, and it emanates events. So that's all it does. But to get a subscription service up, or any Grails app up in our environment, we have this set of requirements. You have to have application monitoring. We always have to worry about security. We have to have the server set up. We have to have builds and deployments. So we have a lot more concerns that we have to do just to get this application out than just the application. So I'm going to go through how we actually built our service and call out what things we were able to reuse to make that a much easier process. And we've got it to the point where we were able to roll out this particular service. This subscription service took us about 3 weeks to roll out up through QA. There's, of course, some stall to put it into production only based on business needs. So, but with all our reusable components, we were able to very quickly get all of those requirements fulfilled. So the first thing we do, and this right now is very manual for us, is we do the Grails create app, and we start from scratch. We tend to always grab the latest Grails version. Right now we're sticking with 2.3 series. Well, we haven't moved up to 2.4 since it's only milestone, and we haven't moved up yet. We will, if we had a service that we knew wasn't going to production for a long period of time. Microservices also really lend themselves to being the guinea pig for some of the early release candidates and milestones of Grails. We immediately changed the version to Java 1.7 because if you do Grails create app with 2.3, you will get a 1.6 app, and we want to just from the start be on 1.7. We do our standard fork mode configuration, which is remove it. My recommendation to everyone, if you are having issues with fork mode, just remove it. And I believe lots of people have said as such. The next thing we do is we add our internal Nexus server to the repos. And that's basically our base project setup that everything has to go through. Next, we go and set up our plugins. We are going to add all our normal plugins, and that's could be database migrations. It will definitely be some of our internal plugins that have to do with security and health checks. We then remove all the extra standard plugins, which is everything with resources. Because we're only exposing a REST endpoint, we have no GSPs, we don't want to use the resources plugin. So we remove all of those right away. We also adjust then to configure Gorham. So most of the time we're switching over to using Cassandra now. So what we like to do in that case is we set the Hibernate Gorham plugin to test so that we can use an in-memory H2 for our testing. And then we have, when it's every other case, it uses the Cassandra Gorham plugin that's been worked on. And so we get that configured and we get all our data sources configured. And then we also set up Cucumber. So we always have all of our features in the Cucumber directory, and we set up kind of the default glue that needs to go in to get the Cucumber the Cucumber plugin to run. The next step is we actually get to commit everything. So you'll note we haven't done anything differently across apps yet. So this is stuff that we would like to figure out a way to standardize more, but right now it doesn't take that long to do all of these steps. So once you have a standard process that it's a pretty easy checklist for anyone to follow, all of your Grails apps will be set up close to the same, and that will give you a good starting point, because when you're working with these microservices, you're really going to want anyone to be able to jump into them easily and understand as much as possible, have as little learning curve as possible. And by standardizing these setups, that's what we've done. We then set up a CI job for every new Grails app we build. We set up CI right away, and then we bring up a dev server. So that's where the point where we actually start working on special concerns. Anything that is actually part of the subscription app, instead of just the boilerplate setup of our Grails apps, starts at this point. So we've standardized on making sure we have CI and a dev deployment all set up before we even move on. A lot of this will come out if you're not lowering the barrier to really get these services out to servers quickly and easily, because with microservice architecture, you're going to end up with a lot of these services. Like we're at 8 right now and plans to have 4 to 5 more in the next few months. So it just keeps growing. So we add all our scenarios using Cucumber. To me, it's felt like the best way to keep our testing dry. And I have some examples, which are hard to read there. So this is an example of a very similar scenario we'll write for pretty much any simple REST endpoint is a 404 case. The next thing we then do is the 200 case, and we get a valid response back. Now, with both of those tests, using Cucumber, we're able to only have to write 4 step definitions because we're able to use parameterization right here and easily check the response code of all the different items. The other difference is that our givens have to change, of course, per application Our givens have to change per test case most of the time, because that's usually what's setting up the differences between the same actions, which is the win case. Does anyone have any questions with how we're using Cucumber or? Okay.
I have a question.
Yes.
Do you use Cucumber exclusively, or do you use something else like Spark?
So we use Cucumber only for the functional. We use Cucumber only in the functional testing, and that's where we we're trying to practice BDD, so we always do the functional testing first, and then we drop into Spock for pretty much all other unit testing. What we don't do a lot of is actually integration testing anymore. So between the functional and our unit testing, we cover 80 to 90% of our code pretty easily. Every once in a while, there's always a case where you want to do some integration testing, and we still use Spock for that. But yeah, we don't use any other test frameworks besides Spock and Cucumber right now. Thanks. So across our apps, we reuse quite a bit of components. So the first thing we do is we reuse our health checks, our security, server setup, deployments, and our Spring integration components. Now, I had mentioned that we use ActiveMQ in the virtual topics, and the way we've standardized on dealing with all the inbound events from our event architecture is actually with Spring integration. So our health checks, we wanted to have a human-readable, easy-to-understand health check that anyone could go hit and understand. But at the same time, we wanted to do work based on them. We wanted to set up a dashboard that could show what the warnings were, where the errors were, across this big, massive problem that you come into when you have. So every app we deploy has, I believe, 3 instances now for an environment. So every data center will have, if we're talking about 6 microservices, we'll have 18 servers that you need to monitor just for this one small feature. So what we did is we standardized on something that looks roughly like this. It's just JSON. It's not that special, but we also have a status code. So depending on what, if there's any critical dependencies, the status code will switch to a 500. And what's actually happening is the load balancer checks only the status code, whereas Nagios and our dashboard tool that we built out sets up to parse this JSON. So we're able to easily get lots of use out of this one endpoint. So the way we actually exposed this was via a Grails plugin we share across our apps. So not only does it give us the controller that shows the outside world everything we want, we also exposed a number of interfaces that you can implement to be the health check themselves, so that this common health check registry will be able to correctly output to the controller everything we need. It's working pretty well for us. Our implementation is actually based around Yammer metrics, and we just have we have a critical path and a non-critical path of health checks, and then if that check is healthy, it's okay. If a check needs to be a warning, you have to actually implement to get 3 states out of a single health check. We don't allow that. We say every health check either passes or fails, and you can decide if that health check is of a warning case or a critical case. Now, what's interesting is when you would want to actually use a warning case, and what we found is when one microservice is making calls to other microservices, we didn't want a single failure to cascade across all of our services and cause the entire dashboard to go red. So what ends up happening is those are required to be the warning state. So they'll try to service request, but most likely throw an error saying it's not it can't process your request at this time, but the dashboard then is red to the point where the failure stops and then yellow on. So it's easy for operations to scan quickly across and find out right where the error is. Now, if you haven't noticed, I'm speaking about operation concerns as well as developer concerns, because as you build out these microservices, it's very important you take into consideration the fact that you're asking an ops team to deal with 20 boxes instead of one that they used to have to deal with. So we try to take them into mind, and we try to do anything we can to kind of lower their burden and make this more automation. So security. We currently do server-server only. So all of these microservices are internal. They're not exposed to the web. Anything that exposes to the web actually has what we call a gateway service. So it deals with usually OAuth to our end clients and then aggregates the microservices on the inside. It's able to do some smart caching and other work there. To do this, we did just a simple token authorization header. It's a stored token, and we rolled our own, basically it's just a Grails filter right now that does this. So our plugin expects a known Gorham object, and the ID is the token. I call out Gorham because we are switching between different data stores, and as our services are evolving, we know we're going to further switch between MySQL and Cassandra and possibly HBase in the future. So we're really leaning on the abstraction layer that Gorham provides to let us switch easily in the future. It uses just a static list of resources of what things to secure, and we intended it to be as absolute lightweight as possible. Unfortunately, this is where we went too lightweight, I would say. We're moving away from it already because we found initially we didn't think there needed to be roles. We thought if you had access to the service, you had access to the service, because that was the only use case we had envisioned in our apps. Since it was internal apps, it was access or no access. And what we found is we need roles because we have certain classes of service, like the subscription service itself, that needs to only allow a very small subset of write access inside the company, and almost everywhere else needs to be read. So what we've decided to do, instead of adding any more functionality to our plugin, is we've started to implement a Spring Security Grails plugin that we will use that will match our internal token auth standards with the headers, but plugs into the broader framework. And this is something, when you're doing microservices, bringing in these kind of large frameworks can sometimes feel wrong, but at the same time, you don't want to just invent everything yourself. So you have to strike that balance between reusability and just small code base. The other problem is we were doing opt-in security, so it was very easy to miss services. And if you are doing something, it's something to think about is whether or not you want your defaults to be opt-in to the secure or opt out of being secure. I think in the future we're going to make our defaults lean towards opting out of being secured. So that way you're very explicit about what things are publicly exposed. So how we actually shared these two plugins, and we have a few others, but they're more business logic and not that interesting, is we use an internal Nexus repo, and we release plugins to that using the Grails release plugin. It works very well. It supports versioning, which is key. There's a lot of other methods to share plugins across apps, and if you can't use versioning in your scheme, you don't want to use it. The dependency resolution works just like everything else in Grails. Any other normal plugin that you would get from Maven Central works fine with your internal repo. So that's key that we wanted. The one thing is changes don't reload, and I only call that out because if you've done inline plugins or things like that, people are very used to being able to quickly iterate on the plugins and have their changes immediately felt in the app they're working on. Just by the nature of the way you're importing this and using versioning, it's not going to happen, and that's fine. I just be aware that it takes a little bit longer to develop plugins than it does develop a feature in this app. But this is my kind of guide I like to use for internal plugins. tend to adding features that allow for customization, because you may have 9 of your apps that use the feature one way. Just allow extension points so that 10th app doesn't need to roll their own and they can just extend with the known constraints. And even then, in the microservice architecture, I'd almost say step back and make sure you really need that customization, and make sure that 10th service can't just use the same defaults. Each plugin is its own real thing. It's not a small little throwaway library. It needs CI. It needs code narc. It just needs to be treated as a first-class citizen in your overall workflow. So once again, use versioning and actually have a versioning standard. Personally, we use semantic versioning, and so we can, with that, describe breaking changes or non-breaking changes, and using your CI build to actually push out snapshot versions we find that very helpful. So we may have 2 apps that we're testing with this latest version of the plugin, and as we make small incremental changes, we'll have our CI push out snapshot builds of it, and then we're depending on, let's say, health check 02-snapshot. But of course, you have to be careful because it's still a snapshot. And you will, every once in a while, we've had issues where we didn't remove snapshot when we should have, and changes got in that probably shouldn't have gone out. But we've been much more careful about incrementing minor versions, and that we've been much more defined about incrementing minor versions, and that has helped quite a bit. So next, I wanted to cover the server setup, and yes.
Do you use maybe Grails or something like that to push the snapshot to the Nexus?
We use the Grails release plugin for, yep, and we're able to specify our repo, and we push it with the CI builds. Right now, we don't have an automated way to do the final releases of the plugins, so that's still a manual step, which I'd like to correct. Because to do that, you have to remove the -snapshot version and push it up. And I honestly haven't dug in enough in that area. There could be ways of doing releases to release snapshot and then release final and have it all automated in a much cleaner way. The other thing we like to implement is tagging. Since we use Git, we use tagging. We tag all our releases, and making sure all of that's tied together is important. So this is where I'm going to show Ruby, and sorry, but right now we use Puppet to automate all of our server setup, and you're able to use classes inside of Puppet to share functionality down. So we set up classes in Puppet are effectively a group of settings for a box. I'm going to say a box. It's close enough. And what we've done is made a standard setup for a Tomcat server. So as an example, to set up everything we have to do to set up an app for this subscription service we talked about is here. So compared to saying what sudoers you have to use and where to get Tomcat and everything else you have to do, we've put the time in to make in particular, this right up here where you see class standard Tomcat 7, that's where we're specifying what class to use, and that's where we're able to reuse all of our server config. You'll notice we're passing in a different heap and permgen and minheap, and that's because we actually share this Tomcat with non-Grails apps as well. So the defaults they use weren't the defaults we wanted. So that's one of the customizations we make. The other thing is down here at the very bottom, you'll see some Nagios stuff. And as I said, since we use the health check plugin, we're exposing a controller @/health, and that's this controller. We just let our internal monitoring know, and that then automatically will add it to dashboards and get everything set up. So the more you can automate, the less hands you have, the better. And then this is how we do external configuration. So the other item that we really need to deal with is external configuration for Grails apps is relatively simple, but we manage it with Puppet. So that's really all this thing does is generate a file at the correct location, and there's a template. But what I would call out is if you are using Puppet or Chef, either one of these are ERB files for your templating. So make sure that you're not double checking, but you're gonna have to test your configs as they come out, because they've sometimes bled Ruby comments and things like that wouldn't affect a Ruby thing into a Groovy file, which will then have a problem. Currently, I don't know of any configuration management tools that are based in Groovy. Otherwise, I'd probably be trying to get us to use that instead. But that's my personal bias. I know there's also Chef and I believe Ansible are other viable alternatives besides Puppet. I'm only showing Puppet because we've standardized on it in our company. In no way am I endorsing Puppet. I actually prefer Chef. But I thought it'd be better to show you real code. So the next step is you have to automate deployments. And by have to, I mean you absolutely have to. If you have six apps that for one feature that are going out and you need to make some changes, you can't manually sustain a continuous delivery environment without automation. We automate our deployments via custom bash scripts kicked off by Bamboo deployments. It works. I think is the best. Like right now, the bash scripts are relatively simple. They SSH in, SFTP a file, the war file in, and basically boot the box. So the only thing we're changing per service is the server list, what artifact to deploy, and deployment permissions. So by automating this, we also wanted to expose it internally to different teams. So for example, the QA environment, any QA in the company can deploy to at any time. They control that deployment. And then within each individual teams, we can deploy to our dev boxes or QA. But that's the one thing we change per service is who's allowed to deploy these services. One good example is I built out the subscription service and I have a team out in California that depends on it. And we've given them permissions to deploy to QA as well, since every once in a while they'll be looking at our service and realize that dev doesn't match QA, and they'll just go ahead and run the deployment. And it's usually because I deployed it at like 4:30 and I left, and they still have 2 hours of work left because I'm in Central Time Zone. So we've tried to do that. We also use Spring integration for any of our consumption of our event system. Now, we actually share a lot of needs with everyone that's using Java and Spring integration, because we're not the only ones that consume Spring integration. So this one is not actually a Grails plugin. We built this as a shared via jar. And I wanted to call out this example because there's no reason you need to make all Grails plugins. There's no reason you can't still go back to good old-fashioned jars for libraries to share across your applications. The only time we're really using plugins is when we have specific Grails needs that we're changing. And we've actually made a few shared jars that then end up wrapping a plugin full as well. So we'll have a plugin that wraps the jar and adds the Grails components, and a jar that's shared across all of the company. So we expose a simple POJO that represents what our internal idea of an event is. And the reason that's important is with that exposed, we can use the Spring integration JSON marshallers to make sure everyone's acting on the same event object. In eventing, we actually guarantee delivery, which if you've done anything with eventing, you'll know by guaranteeing delivery, you're saying that you have to accept duplicate events. So what we do is we have a deduplication filter that works based on a UUID and some storage. And this jar will actually exposes an interface called, I believe it's event store. And basically it's an interface that you can implement in your own app to say what kind of event, how you're going to store that you've actually processed events or not. And you have just a small set of constraints you need to implement towards. And so that's another thing. We try to use interfaces to enforce contracts as much as possible when you're sharing across many apps like this. We also built it to include the least dependencies possible, so that forced us to write it in Java. So since we didn't want to force our old Java apps to include Groovy as well, and we weren't doing compile static or anything like that, we ended up doing Java 1.6 for these because we have a couple apps that still use 1.6, which is just sad. Does anyone have any questions about using the jar, or straightforward? Okay. So I want to call out some pitfalls, and this is where, if you guys have a solution to one of my pitfalls, please shout it out. So poor communication between teams gets 10 times worse with a microservice architecture. So we had a team that we weren't well connected with. And basically, since we're no longer forced to be in the same code base, we're not forced to talk to each other. And we're not very good at talking to them. And we further and further diverge in our understanding. So if you have poor communication between teams, you're going to make it worse with this architecture. And it's really interesting to kind of see how your architecture of your app influenced the communication patterns and vice versa. So to see all of the communication patterns really inform what kind of app you build. The next pitfall is coordinating releases. And you want to try to have it to avoid having to say, well, service, the subscription service, the event API, and these two social services all need to deploy on Tuesday. Because it's just that many more things that could go wrong and force you to roll all those services back. So the way we try to avoid this is with kind of forced ordering. So we'll say whatever the root dependency is, that one has to go out first. And then once that's released, we'll say, okay, you guys can release one at a time. And we try not to say coordinate on the same day, but we still have to coordinate in the forced ordering. And if you do it wrong, it's very easy to end up with a bunch of features that don't work because one of your microservices didn't get deployed by a separate team that had an incident come out and they just didn't get their QA done and decided not to deploy that week. It's tricky. Development to spec versus finished service. So we've run into this a lot where most of our microservices are new. They may only take a few weeks to get out. But if you're on a tight timeline, a lot of developers will tend to not want to use a service until it's finished and actually exposed out to QA at least. And what ends up happening is you end up introducing a lot more lag because there may be other factors causing you to not be able to deploy to QA, which might be lack of servers or other operational concerns because each one of these is a new app. If you can get people to develop to the spec of what you publish and to the intent of the REST service or the events, you can mitigate that a little bit, but we found it very hard to overcome. Most of our teams want a finished service before they start developing. And I've actually caught myself doing this quite a bit. I leave in snapshot versions of dependencies because I'm careless sometimes. And it's really bad, and I don't have a great way of automating that away yet. It's something that I should be able to have as a check as part of the deployment or something like that. It's just, I haven't automated it, and I've made the mistake a few times and realized that I released a snapshot version out to production, and it's never fun, but it hasn't bit us too hard yet. So this is my personal microservice checklist. This is everything I think you absolutely have to have in place before you can do microservices I would say in Grails, but probably honestly everywhere. You probably can't do microservices unless you have these items in place. And that's, you need a very low overhead to start new projects. So, for example, if it takes you 3 days to get a new Git repo because you don't have permissions to create your own, thank you, that's a huge problem. You need a very low overhead. You need an internal Maven repo. It can be Artifactory, Nexus, either one's fine. I would say Artifactory because I've had less issues with it. But you need an internal Maven repo to help coordinate, especially internal plugins. You have to have automated deployments, just period. You need server configuration management because as you continually add more and more servers, you're going to swamp ops too fast unless you have some sort of configuration management. And you need really good team-to-team communication so that you're not all constantly out of sync. I have a few open questions that I don't have good solutions for, and there's something you guys should probably contemplate before you get too far into microservices, and that's the correct size of a microservice. So I say a single concern. Good luck having everyone agree on what a concern is. So I leave that to you guys. And then the other is pure REST versus RESTful. So pure dogmatic REST becomes very hard where you only have the REST verbs compared to RESTful where you get to cheat a little and have a logout link, which isn't technically REST. And then the other one is security, is centralized versus decentralized. So if you have a centralized security system, it's much easier to push that out everywhere, but at the same time, you now have a central dependency. And decentralized is great, but you have to manage it. So thank you very much. And there's time for questions, 3 minutes of questions, if anyone has anything. Yes?
How do you deploy each service? Do you deploy each microservice in its own machine? Or do you deploy or something like a distance?
Every microservice is its own machine. So yes, we use OpenStack and Puppet, and every application, every microservice we build has its own application manifest. It is completely contained within itself, and yes, there is some overhead to that, but it seems to be the best solution we found so far. We haven't had a lot of good luck running multiple wars in a single Tomcat.
So have you ever considered using the standard plugin?
Though.
It generates a fat jar, so you can deploy like the Greach or like.
Yes. So.
You can have different services in different ports.
Yes, we haven't done fat jars in the company. Well, I should rephrase that. When we started this project, nowhere in the company had ops deployed a fat jar, and they weren't comfortable with it. So once again, this is the give and take with ops. We have done a fat jar now with Spring Boot, and we're using that as an evaluation to decide whether or not we liked it. But to let you know, we use Spring Boot in the integration mode only, no web front end, no web interface or anything like that, no web endpoints, because we'll just use Grails if we have web endpoints at this point. I also don't know that our operations team would want multiple services on a single box, because since we're trying to move towards getting them to deploy images, so deploy an entire box and the services running on it as an entire image instead of thinking about deploying apps to servers. So that's the direction I think we're going. It doesn't mean fat jar couldn't work for that as well. Thanks. Yes?
How do you handle changing the HTTP APIs you're exposing internally? With the dependencies between them?
So since we're doing pure REST, according to us, I should say, because that's a little contentious. We use media queries and the accepts header and to actually version what comes out of the API. But if you want to version, like change the functionality of the API, I'm actually in the camp that says you can probably expose a new endpoint at that point. If you're doing a REST resource that only has the verbs available, you can version it with what it looks like with the media queries easily. Ooh, that moves. With the media queries relatively easily. And then whenever you need to add new functionality, it's a new endpoint. So, but that falls into the RESTful versus pure REST. If you do a little more RESTful, there's something to be said about adding maybe the version to the URL, but at that point you can't store URIs as IDs, which we actually do. So, thanks. Anyone else? Nope. I think we're out of time too, aren't we? Oh, okay. Well, I don't have anything else.
Thank you.
All right, thanks.